Finish your presentation.
Yeah.
Ah, that's a problem.
How many pages should I leave for the notes? Two class?
Two class?
Ready?
So one class? Oh, two
How many
class.
Two classes.
Two class.
So how many pages should I leave?
I think here? Yeah, did I try make a meeting?
Good, correct, good.
Oh, how many pages?
One,
two,
three, four, five.
No.
Yeah, you missed a lot. You missed a lot, Go. You have to watch those videos, okay? Missed a lot.
So I'm sick for a few days and
Yeah.
I'm really nervous. I'm sick in tonight. Tomorrow 9 o'clock is the presentation.
9 o'clock.
Yeah.
And the first.
You're first? Exciting.
I'm the last one.
Exciting.
We are together, I think.
Who's your teacher?
I don't know.
It says new.
It's new?
Oh,
Oh, okay.
that's good. Neil is good.
And
Connell's the hardest.
Conan?
Yeah, he's the hardest.
The business teacher?
I don't know what he teaches. Maybe he teaches.
it's
Connell.
biology.
No, not Colin. Connell.
Connell.
Yeah,
Have the glasses?
yeah,
So the same office with now.
yes.
Oh.
He's the hardest. He asks the hardest questions.
Oh.
Neil
you
is-
ask questions.
At the end, Neil's good. Neil asks easy questions.
So teacher will ask questions as well.
One question, maybe two.
'Cause Colin told us we need I need to prepare a question for Ben, and Ben will ask me. So that's why we can be saved.
No, usually the teacher asks the question.
Really?
Well, I don't know, it depends. Who do you have, Neil? Okay.
Yeah, timetable is.
Someone will ask you a question.
I think only 4 in a class.
Yeah, because engineer only 4 of us.
And maybe only 2.
Might be.
No.
Maybe. You don't know, Ben. Maybe just the 2 of you. Right? Okay, we'll continue now. Interference. Go, you ready?
Hate referencing.
I know, everybody does.
1, 2, 3, 4.
You got that? Yeah? Okay. So I think what we'll do, we might do a tutorial in the second class. We'll see how we get on. Okay. See, these lessons are big lessons. We have a lot to do in this lesson again. A lot to do. Okay. Now, before you write that down, before you write anything down, is this a word you know in English? Interference.
And the reference.
Huh?
Reference.
Nothing to do with reference. Interference.
I know inter.
Yeah?
Inside something.
Yeah.
And I don't know.
So inter is like between.
Yeah.
Or in, yeah. So interference, you've never heard of this word before. So you know when you're talking on your phone and you can't hear the person, sometimes people say, oh, there's interference, meaning there's something affecting the phone call, like the signal.
Okay.
You know, like you know when you're watching TV and then maybe it's not so clear because the weather's really bad. We can say the weather is interfering with the TV. Yeah? This is affected, yeah. So precisely in physics, interference is when you have 2 waves and they combine to form a new wave, and the principle of superposition states the net amplitude of the new wave at each point is the sum of the amplitudes of the individual waves.
Oh,
Relax, I'll explain it. So the first part, let's look at this together. Interference is when two or more waves. Okay, so let me draw that. You have two waves. So there's one wave, and there's another wave. And they add together to make a new wave. And the principle of superposition states that the net amplitude, so in the new wave, the height here will be the sum of the amplitudes of the individual waves. So this height here is the sum of these heights. So for example, this goes up and this goes up, so this goes up. Okay? This goes up, but now it goes down. So it goes down a little bit. So I think it's hard for me to draw, but it would look something like this. Like for example here, if I just mark it off, this height here plus this height here will equal this height here. If this is like a t, and this is t, and this is t. So if this is 1 second, and this is 1 second, and then you have 1 second here, this height here will be this height plus this height. That the heights add together. Okay, so if you have a big wave plus another big wave, then that would equal a really big wave.
But what's wrong with this?
Huh?
The shape y is like this.
Oh, because like for example, maybe this is 10 centimeters, okay? And maybe these are 1 centimeters.
Okay.
So as this is going up, this is going up, down, up, down, up, down. So maybe the heights are like for example, this one might go 1, 2, 3, or whatever. So you might have like 1, 2, 3. But this guy might be going plus 1, 1, 0, 1, 0, 1, 0. So it'd be like plus 1, plus 0, minus 1. The heights add together.
But time is the same.
Yeah. Okay, think about it like this. I'll give you a better example. You did this in maths, didn't you? You did like a sine graph. Okay, so let's just say here, this is height and this is time. So you have height equals A1 sine B1 t. Something like this. Okay. And then maybe you have another wave, and maybe it looks like this. So maybe this wave, H2, is A2 sine B2 t. If you add them together, you'll get a wave that looks like this. And its height, H3, will be H1 plus H2. That's all.
Okay.
I'm going to make you a graph. I'll make you a beautiful picture. Watch my beautiful picture. You don't like it, or you don't understand.
I understand.
Are you sure?
Yeah.
Are you sure? You understand? Can I trust you? Right, no, don't write just yet, don't worry, because I really want to make sure you're clear on this. I want to draw the picture. I want to draw a beautiful picture.
Oh, do you have grade?
Hmm?
Do you have grade?
Grade?
For exam? The score.
Yes.
Do you remember mine?
No. I have to give it to you, don't I?
So, the Ben has one.
Yeah.
So I just lowered than him one
Oh, maybe.
levels.
No, I don't remember.
Did you tell me?
I think, okay, I think it's like 59 and 61.
Okay.
But maybe it's 61 and 59. But I said it doesn't matter because both are 6 out of 10.
Yeah.
Yeah. Right, so let's say 2 sine 3t. And I'll graph that. There it is there. Okay. Whoops. Oh.
What?
Whoa! There, okay. Now, let's say I graph 0.5 sine 5t. Let me draw that. There it is there in blue. Now let me add these two waves together. Just simple adding. And I graph this. Ready? There it is in black. Can you see? So what happens is, when the red one goes up and the blue one goes up, they add together to make a bigger one.
Okay.
Now, you notice how the blue one starts to go down. So, okay, here the red one is really big, and here the blue one is a little big. So together they make something a little bit bigger. But notice now the red one is under, so now its height is negative.
Okay.
So that's why the black line is now under the red line, because it's the red height plus the negative blue height. It means the black height goes under now. You can see that? So this is called the principle of superposition. And the principle of superposition just means that if you have two waves, the new wave is just the sum of the two waves. The simple mathematical normal sum. Nothing special, okay? Right, now this definition is quite difficult to remember. So you need to do your best and write it down carefully.
You studied in math, English, in chemistry class.
Nah, today?
Yeah,
Nah.
like math as field.
Now you can study more English.
These.
Got it? Got it? Okay. So here's a beautiful picture too. That's wave 1, that's wave 2, and that's the result. Yeah? So, as carefully as you can draw this.
No, that's impossible.
Ah, no. You can draw it like, you can just draw it like what I did, you know? Big black wave, small red wave, makes a blue wave like this.
The picture is perfect, like the curve adds together below, above, something.
The reason I'm asking you to draw this is because maybe if you draw it, it will help you remember. And also, maybe you need to draw it in the exam. Sheshe means thank you in Chinese.
Yes.
I learned this. Great job.
Okay.
Okay? Good stuff. Beautiful. Beautiful. All right, let's continue. So, yeah. We say two wave sources are coherent if they have a constant phase difference. Now, do you remember the meaning of phase difference from last week? I think you were in class for this one, Go, I think. Phase difference, yeah. Do you remember this? If you go back a few pages, I gave you all the terms. No, before that. No, before that.
It's this one.
Yeah, the phi.
Fine.
Before that.
The time differences.
Oh, wait. Yeah, this guy. Yeah, phase difference.
Oh, the time difference between the
Yes.
two. Oh,
Yeah. So look. No dictionary.
Crest.
What's crest? Even Ben knows that. Ben, tell her what crest is.
oh, the high,
Good man, Ben.
The what?
Tell her again.
Ah, yeah, here.
the high.
Yeah, okay. So
You know, you need to improve your English. You need to be more like Ben. He's studying very hard.
So it's called peak as well.
Yeah. And what's the opposite? Crest and...
I know it's bottom, but it's not bottom.
Yeah, no, it's a different word. Trough. Okay. Anyways, two wave sources are coherent if they have a constant phase difference and the same wavelength. Now, here's a picture, okay, to explain. So you see here, if you look at the distance from crest to crest to crest, that's the same here as the distance between the crests. So they have the same wavelength. But notice, the crest here and the crest here, they're in different places.
Yeah.
And this distance here
Yeah.
is the same as later. The crest here and the crest here, the difference between them is the same. So we would say these two are coherent. They have a constant phase difference and the same wavelength.
But if I only read the definition, I will draw the same two wave. I can't think about like they are not in the same top.
What do you mean? Like this could be like two lights.
No, I mean if I only read the definition, what I think is the same. The two wave is the same.
That's also coherent. Yeah, so you're right, Gao. If you had a picture like this, you mean like they match up?
Yeah.
Yeah, you also say they're coherent. Yeah. Okay, if you can write and draw.
I think I watched the movie called this one.
Coherence.
It's kind of
What
horror
movie is
movie.
this? Horror movie. So Korean?
No, not correct.
American?
I think it's American.
I don't know.
show the picture?
Of course. Yeah? Got that, Ben? Okay, good job. Okay, now, when two coherent waves propagate, does anyone remember this verb propagate? No? No? Yeah, go on.
They meet together?
They just propagate just means move. So when two coherent waves move together from two different sources and they meet, then we say the path difference is the difference in the wavelength distance each wave travelled. And we express this as a constant times lambda. Now I'll try and draw a different picture here. You can't really see in this picture, it's not so clear. So I'll draw a picture here. Right, so here's one wave, and here's another wave here, and let's say there's a wall here, okay, and the wave comes along from the first person, so that's one wavelength, yeah? 1, 2, 3, 4. Okay, so that is 4 wavelengths, and the other guy here, let's just say 1, 2, 3, and when he hits the wall, he is 1/4 of a wave into the next wave, whereas this person was at the end of the wave, so they were like 0 lambda, and he was 1/4 lambda. So the difference here is 1/4 lambda. That's called the path difference. That's called the path difference. So you see in this picture here, look, the path difference is 0. You can't quite see, but this wave finishes at the end. It goes up, down, up, down, up, down. And this wave here, look, up, down, up, down, up, down, up, down, up, down. And it finishes at the end as well. Now this one here, the path difference is half a wave, because you can see in this one, oh, if you can do your best, you see that one there, down, up, down, that finishes at 0 wavelength, 0 lambda, whereas this one is up, down, up, down, up, down. I think it's it hasn't quite finished. It needs to go down a little bit more, because down, up, yeah, it needs to be like finished here. So there's half a wave still to go. So the difference between the two journeys is called the path difference. So for example, what did we say here? This was 4 lambda, wasn't it? And this one was 1, 2, 3.25. So that's 3.2, wasn't it? 3.25 lambda. So you can say the difference here is 0.75 lambda or 0.25 lambda. I think it's the same thing. Yeah.
Is the same?
Isn't it?
Why not just 0.75.
Maybe you're right, Gao. Maybe I'm wrong here. You're right, sorry. I think it's 0.75.
See, I think if we look total, it's 0.75. If it looks last part.
Yeah, you're right. Sorry, that's what I'm doing wrong. Do we look total or last part? Oh, I'm not sure. Let's count. Maybe it is total, Gao, but in the questions and the exam, you only just care about the last part.
Did we give the hint?
They usually don't tell you this distance anyways.
Oh.
So you're just looking at the last piece anyways.
So it's quarter?
I think I would go a quarter, yeah.
Okay.
The reason it's important is because if the two waves finish here and the other one finishes here, then in total you have 0. But imagine the first wave was like this, and then the second wave was, oh, I don't know, up, down, up, down, up. So when you get to the end, you finish on this much. It's not 0. You have a little wave left.
Mm-hmm.
Yeah. So we usually say the answer is k lambda, where k is between 0 and 1. And the most important one is this one, when it's a half a wavelength. And the reason for that is because there's one wavelength. Oh, sorry, let me draw again. There's one wavelength, and then here is half a wavelength moved. So that would be like, oh my goodness, I'm so sorry.
It's okay.
It's half a wavelength different. But when you combine these at the end, do you see here? This is negative and this is positive. And this is negative and this is positive. So at the end they come together and then they're gone. They cancel. So you finish on nothing. You know, that's important. This is the important one. If the path difference is half a wave. Okay, do your very best to write this down, please. I won't make you draw the picture. It's okay. You don't have to draw the picture for this one.
So the path difference is half lambda.
Yeah.
But what's that called when the main type 0? There is no wave?
Correct. No wave, yeah. How's your cat?
Good.
Good?
I think he has some disease, like no disease. He's just sick.
Sick. Illness.
Yeah. He usually like have sneeze during the sleep.
Maybe it's the weather.
Cough. Don't know. That's some illness usually happen to cats.
Oh really? And Ben, how's your bicycle?
So today I think.
It's nice.
Good. You weren't at the sports day on Friday. Remember the sports day?
Uh,
Oh, you were at the sports day.
I played volleyball.
You played volleyball, yeah. You weren't at the sports day, Gav.
I even go to school.
Yeah. You didn't get to see me in the bicycle race.
Oh, really? You had bicycle race?
The teachers had a bicycle race.
Ah,
third.
who's the first one?
I was third.
Who's
Colin.
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 Ah,
And
who's
then
the
Neil.
Neil.
Yeah.
Ah, okay.
They had big bikes.
Firstly, Neil is the first one.
Yeah. Yeah.
And you keep the third.
I third, yes.
How many person?
6.
I think only 3%. Joking.
No, I wasn't last.
But I watched the video in Instagram or
Yeah.
I don't know, because I see
The tug of war.
you
Yeah.
are the first person. I saw you in your team. You are
Oh
the
yeah, the teacher team.
Yeah.
Yeah.
Okay. But you won, I saw.
Students are so weak. They don't eat right, you know, they just eat cookies and frappuccinos. Alright, you got that?
The teacher.
You don't need the picture, it's okay. Now, I will tell you, this is very important for CDs. You know, DVDs?
Yeah.
Yeah, this is very important for. You'll see in the question why it's important. Okay, so we have different types of interference. We have constructive interference. This is when waves combine to form a bigger wave. Destructive interference is when waves combine to form a smaller wave. So, for example, here, maybe you have a wave plus another wave and it makes a bigger wave. Or you could have a wave plus another wave makes a smaller wave. This is called constructive if it's bigger and destructive if it's smaller. Okay? Now you can have something called completely destructive. What do you think that might mean?
No way.
Completely destructive. Yeah. No wave. The waves cancel each other. So here's an example. This is completely destructive. They're gone. And this is just constructive. They add together and get a bigger wave. Okay. I don't really think you need this picture. I think the definitions are good enough here.
Do you know any buses can go vehicle? Any buses, any transport way can go vehicle?
Wicklow? Where in Wicklow?
The mountain.
Oh, you want to take a bus?
So what's that number? It's usually bus or no?
Depends which mountain. There might be a Dublin bus, but there should be also a private bus too. You want to go walking? Camping, yeah. I think you might need to use one of the private buses, you know, from the city centre.
So it's not like group people to there. I don't want to join a group like
No,
10
no.
people.
No, you can just take the bus,
Cool.
but you can do your own thing.
Cause I did once in 2 years ago, I think.
Where?
Wicklow.
Oh, really?
And that time is December, cause
That's cold.
and dangerous as well. And the top they have snow and full of snow in the top.
Yeah.
That's good.
Exciting.
Because last time I've been there is my uncle drives me. So
Oh, he drove you. Ah, okay.
drove.
He won't drive you this time?
Don't know, because I don't want he follow me again. So
Okay.
I think maybe I with my friends. So
You want a private camping trip? No uncles.
no uncle.
No uncle. Okay, you got this? Now, do you have headphones at home? Like good headphones?
Not here.
Not here, but what ones do you have at home?
Like no this one.
No, headphones for music.
Oh,
You know, headphones. Earphones.
Earphone, a big one.
Yeah. Do you have them at home?
Yeah.
Which company?
This one.
No?
Was like kind of like red platter. Like kind of like this. You know this one?
No.
I don't know how to call it in English.
Okay. Ben, do you have one?
I have a small.
Yeah, okay. Do you have the big ones? The big ones?
No.
Like, for example, Bose or Sony? No, okay. Which ones do you have?
I think you said like Bose or something.
Maybe it's Bose. Good, okay. Have you ever heard of ANC? You can check on Google. ANC headphones. Go give that a check. You can put it in Chinese, see what you get.
Oh, it's called Beats.
You have Beats? That's not a Greek letter. That's an English letter. Like this.
A B.
A B. Yeah. It's not Greek.
I think it looks like Greek. Like
No,
Beats
it's
or-
English. It's English.
Okay.
Right. Did you find this ANC headphones? Did you find it in Chinese? No?
Yeah, I found something. Like, the Alibaba.
Yeah. But can you see what ANC is?
No, don't show ANC.
Okay, I'll explain. So, you maybe have heard of this before. Let me draw the picture. Here is, are you looking? Go.
Active noise.
Yeah, active noise cancelling. So here's your head. Okay. And here are the earphones on each side.
It's like plastic bag.
Yeah. Right. So, this is what happens. It's on YouTube already, don't worry. So, this is what happens. You're trying to listen to your music, but you have noise coming in from the outside. Okay? So this is a problem. So you don't want the green, you only want the red. Okay? So what these ANC headphones do, what they do is, when the wave from the outside comes in, there's a little microphone on the outside, and it listens, and it makes a wave that is the opposite. So for example, if this is going up, then it'll make a wave going down. So when this comes in, it cancels with this one. So what happens is this comes in, there it is there, and then it makes a wave in the opposite direction. So the two of them cancel, so that your music can go in without hearing the outside. That's how the ANC works. It uses destructive interference to cancel the sound.
That's why accidents happen.
Well, but sometimes it's to protect your hearing if you're in a noisy work environment, if you're in a factory,
Yeah.
you know. Now, this works really well when the noise is fairly continuous. So for example, if you're listening to, like maybe you're on a bus and you have the engine and the engine's going, it's very good at finding that and then making an opposite sound and cancelling it. Okay, it doesn't work for sounds like me speaking. So if I start to speak, my wave is too. It's not easy to cancel it. The shape is too difficult, you know. But for a sound like on a plane, on a train, on a bus, is very good at cancelling this sound. These low sort of sounds like this, you know.
So, what if they have the same wave?
The same?
You know, there's some people, special people, if they put a glass.
Yeah. So if it's the same, it will sound louder. So if you had a sound coming in and it made it the same again, it would make it louder.
Oh yeah.
Yeah. That's the same idea as that then, yeah. So this is a good example of completely destructive interference. Do you think you have this on your headphones?
Don't think so.
No, you. I don't know if you have it here. Okay. So the next one now. Maybe you've seen this before.
Right.
The double slit is a famous experiment done by Young. So what he did was this.
Young's Marshals? Same people?
Might be the same person, yeah. Yeah. So you have your sun. And then what he did was he had one slit. A slit is just when you have a piece of paper and you make a little hole, just a hole here. So then what would happen is the light comes in like this, out from that hole there, okay? And then he put up another piece of paper in the dark room and had two slits in this one. So then you have two lights coming out. Now, it's going to be hard for me to draw, so what I'll do is blue is crest and green is trough. So crest, 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 crest. Okay. Crest, 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 crest. And then here, trough, 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 trough. So what happens here when the two crests meet? What happens to the wave? Does it get bigger or does it get smaller? So crest, crest, bigger. So you see here it's big. Okay? But what about when the green meets the blue? Like here, cancels.
Maybe cancel.
Will cancel, it will cancel, yeah. So what will happen if you put a screen here? What Young noticed is you get a very bright spot here, but then you get darkness here and here. And then you get a bright spot again. And then you get darkness again. And then you get a bright spot again. And the reason for this is what's happening is the crests are traveling along and they hit the screen and make it very bright. But something like here, oh goodness. See here, this crest and trough cancel, and so when it hits the screen there's darkness. So you get light, dark, light, dark. This is called a fringe pattern. This is called a fringe pattern. This is a screen. This is one slit. These are two slits. And then what happens is, the reason you get this red one here is when a crest meets a crest. And the reason for the dark one here is when a crest meets a trough.
So how about trough and trough?
Trough and trough will be bright. because if you have crest and crest, so the crest and crest gets really big, and the trough gets really big, so it looks like this. So you still have a bright light. Okay, so I think my picture here is a little bit better than Young's double slit. It's very simple. So what he did was, like here, look. He was in a dark room, and he took a piece of paper, you know. So it was sunny outside. He made a little slit here, so only a little bit of light came in the room. And then he took a piece of paper and then made two slits here, and you put this up against the single light, and then it shines, and you get this picture of light and dark, light and dark, light and dark. And this is called a fringe pattern. And what's interesting is this only happens if they're waves. Waves.
Waves.
Yeah, because think about what would happen if they weren't waves. Like, for example, suppose you had like atoms, like I don't know, whatever, electrons or something. Well, not electrons. Molecules. Yeah, we'll say something big like a molecule. So if the molecules come through the first hole, maybe some of them will come out this hole, and some of them will come out this hole. So then when you look at the screen, what will happen? You get some molecules here, you get some molecules here, you get no molecules here, and no molecules here, and no molecules here. So if you have only two, it's not a wave. But if you have a picture like this, it's only because it's a wave. So this was Young's experiment to, what he wanted to do was to prove light is a wave. So this proved that sunlight was a wave. Okay. Now this is very important for the exam because there's a lot of questions about this. So you can try your best to draw this, my beautiful picture.
Young's double slit?
Yeah.
Slit.
S-L-I-T, slit. It's a noun and a verb.
What's the word? Do this?
I know, do this.
Suicide?
No, murder. Oh no, it could be suicide too. So it's a verb to mean cut. But we usually use it to mean like cut a person. Usually.
I only have one color. I was all black.
Fringe, yeah.
Fringe.
F-R-I-N-G-E.
Does this wall's called?
No, the wall is called the screen. The fringe is the name of the picture on the wall. Yeah? We got that? Okay, let's continue. So, if two in-phase coherent waves are emitted from 2-point sources and then later superpose on a plane, we find that the wave produced on the plane will have an alternation of maximum and minimum intensity. In other words, if the two waves were light waves, then we would have an alternation between bright and dark spots. If they were sound waves, yeah, so that's a good question. This is a light wave. So on the screen you'll get bright, dark, bright, dark, bright, dark. But suppose instead of light we used a sound wave. What would you get here? It's not bright, dark, bright, dark. What would you get?
Louder, quiet.
That's it, very good. Loud, quiet, loud, quiet.
How can I get loud, quiet in the wall?
Yeah, so if you... I did this in class. You can do this in one of the classrooms. So if you had your sound wave and then you ask a student to walk across the wall, as they walk they will hear it going loud, quiet, quiet. Yeah, really. Yeah.
There's another thing. I watched a video like it's person talking this corner, and then we see in that corner something like really big, like train station. If the person in a corner and another one in opposite corner, really far away, if they talk to the corner, they can sound each other. Is that true?
Depends on the shape of the room, you know. Because we were talking about this in the last class. Sound can reflect.
Okay.
Sound can also diffract, which means it spreads out. So it's possible that the room could be made so that this happens. You know, it depends on the shape of the room. Okay. So I call this a fringe pattern. That's fine. The full name for it is not fringe pattern. The full name is called 2-point source interference pattern. Now just write that down, but don't worry. In the exam, you can just say fringe. 2-point source interference pattern. Okay? Yeah? Now, I drew the diagram already. So, the way this is done in the lab is by using something called a diffraction grating. And the diffraction grating is just a piece of plastic or paper with many slits. Here's a picture of it. So can you see that it has lots of slits? So what happens is, because the light is so small, it's too difficult to try and have just to have 2 slits. So instead what you do is you have many slits so that when the light comes in it should split between 2 of them, two pairs. So it makes it a little bit easier to do the experiment because you can just, it doesn't really matter because the light will hit some pair of slits. This is called the diffraction grating. It basically is just this piece here. That's the diffraction grating, okay? And all it is it's usually just a piece of plastic with many slits. So for example, maybe you could have like I don't know, this is 1 centimeter. So 1, 2, 3, 4, maybe like what, 20, 30 slits, you know. I think you can just write this down. Diffraction grating, you can say, is just a plane of plastic or paper with many, many slits in it. That's enough.
So this is slit, not this.
The slit is the vertical. So here, these are called the slits, the holes.
It's called holes. That's called holes. I thought that's the.
No, you're right. You're right. So that's why we don't call them holes, because holes are round. So we call them slits. So to be clear, it's like the holes, but it's a different word in English if it's like this. What's wrong?
I don't know. I feel someone dropped on my head.
Nothing dropped on your head.
Jesus.
Got that? Yeah? Okay. So I need to give you some terms now. So the first one is called slit separation. So what do you think that might refer to? Slit separation, what might that mean?
Like slit?
Ah, no, it's a noun. Oh yeah, no, noun. Slit separation.
Just separate.
Slit separation, D, is the distance between the slits, the two sources. So this is the slit separation. In other words, in the picture back here, it's the distance here between the slits. Okay, so that's called the slit separation, right? So you want to write that down, the distance between two sources. Yeah? You got that? Now, out of power. Now, what do you think fringe separation S is?
It's between the spots.
Yeah, between the fringes. Yeah, between the spots. So, that is the fringe separation.
Oh, between the bright spots.
The bright spots, yeah. The distance between fringes. No pen, huh?
I have.
Do you want one?
No, I have. Oh,
Huh?
I just changed.
Need to change, yeah.
I changed
Oh, you changed it, okay.
this. It's okay.
Got that? Now,
Yes.
the next one is angle. So the angle theta means the angle between, sorry, this picture's getting very messy, the angle between the center here and the fringe. Now you can see there's many angles. So, for example, this one is theta here. Or this one here, smaller theta, bigger theta. Okay, it's the angle the wave makes with the normal. So, okay, you can just write the angle if you like. You can also draw it if you want. It's up to you. If you think you can remember it. Yeah, I'll draw it here if you want, Ben. It's like this. This is the normal. Here's the spot. So we call this the theta. Yeah? Okay. Next one. Distance to screen. That's the distance from the two sources. Okay, so it's obvious. This is the distance here. Distance to screen. Man, I'm so hungry.
So sleepy.
I'm sleepy too. I'm sleepy and hungry.
Should we go home now?
No, can't.
Can't open my eyes.
Oh, I have go to
Later, yeah.
Colin.
Colin.
Why?
For PlayStation, I think.
I don't finish.
Oh, you're in trouble.
Maybe, I think I don't have to go. Right? I don't have to go. Yeah? No, and I don't know. Should I go there?
I don't know.
Who knows?
I think that I finished in
If
this
you
morning.
finish, maybe you can go. I don't finish.
She already corrected me.
He's not finished, you see.
Oh, why?
The order, n, is the position. So what I mean here, for example, the first dot in the middle, we call that order 0. Then the next dot is 1. Then the next one is 2. And then down here, the next one is -1. The next one is -2.
So what is n? Just number?
Just a number, yeah.
Oh.
It's the position, the nth term. Like first, second, third. Have you studied this before, Ben?
Maybe.
Maybe?
No. But this idea, yes, similar.
Yeah, we learned something similar, but it's not physics. I say it's science.
Really?
Yeah, like from, I think that's from China. Might be. I don't know. It's like, no, maybe not from China. I know they have a candle and make fire here, and maybe there's a hole. It's not.
Yeah.
It's a hole, and something like from the hole, and that's the opposite one in the paper. It looks the opposite candle.
Oh, yeah. That's, we don't study that. We don't study that, yeah. Continue. So, for this Young's double slit, we have two formulas. The first one is n lambda equals d sine theta. So, if you want the theta, you need to know the n, the lambda, and the d. And the second one is for the fringe separation. Now, please note, this formula is exact, but this one is only roughly right. However, in the exam, they don't care. You can use this one as equals. It's fine. Okay? So we have two formulas we need. Yeah?
Yeah.
Okay. Let's have a look at a question.
Why Tiago didn't take part in the sport day?
He was in a different country. He was on a business journey.
Business journey.
Yeah, somewhere in Europe. You have to fly somewhere.
Did he back?
I don't know if he's back yet. I haven't seen him. Maybe he's not back.
Guys, I just sent his email before this class.
No, maybe
I heard sharing
yeah,
last Friday.
yeah.
She tell the Tiago see you next 2 weeks.
See you in 2 weeks.
Yeah.
Oh, maybe his business journey's for 2 weeks. I don't know. Are you worried about something?
I'm worried about something.
What? Your application?
No, because we done the application.
Good.
The DIT replied my email and they said something about fees. You will see this website. And I don't know, because I have some students here, they said school will pay these fees.
Application fee? They might, yeah.
Because I'm not sure. Because I think DIT already asked me.
Ask your tutor. Who's your tutor?
Colin.
Ask Colin. He'll know. He'll know. Okay, will we do an example now? Yeah? Okay.
Just
Okay.
one.
Just-
finish.
Well, I tell you what my plan is, and we'll do this one. I'll let you try these for a few minutes. Then I want to give you the answer for the homework. You can check if you got it right or wrong. Okay? So, let's have a look. A speaker is inside a room. It's humming at 2 kilohertz. There are 2 doors beside each other in the room. They're 1 meter apart. A boy walks the hall with the doors to his left. He noticed that as he walks, the sound gets louder and quieter. He is surprised. The hall he's walking on is 2 meters wide. So, look, this is what happens. Okay? You got a room, and you've got a machine here, and there's sound coming out of it, and the frequency is 2000 hertz. Okay? And you've got 2 doors here, and they're 1 meter apart. And then you've got a hall here, and this is, this is 2 meters, okay? And this one here is 1 meter. And the sound comes along, and it goes through these, and what happens is you get your fringe pattern. And the boy is here, and as he walks along, you can hear it getting louder and quieter. Okay? First question. What is lambda? And the speed of the sound is 330. So F is 2000, V is 330. I want the lambda, the wavelength. So how can I get the wavelength here? Which formula do we use from a previous lesson? Do you remember the formula?
V equals F.
Correct. V equals F lambda. So lambda equals V over F. Okay, calculate please. What do we get?
Is sorry. Oh, 2000.165.
Okay. 2. How far apart are the peaks? So that means I want to calculate the S. Yeah? So the S equals lambda D over D, which would be 0.165 times what?
D is 2.
Good. Over
1. Just sorry.
Yeah?
Yeah.
Good.
Where's 2 come from?
This.
Okay.
Yeah. What is the angle of the second order? So look, that's this one. From here to the second one, I want this angle.
Is 2 or
2 lambda
2 lambda?
equals D
D 1
sine theta. sorry, 2 lambda equals d sine theta. So theta is 90.
19.
Oh, 19.
Sorry,
19. That's very different to 90. You can't have 90. What is the maximum order? Hint, theta is less than 90. So, these dots, they don't continue forever, okay? Some point they'll stop. There'll be one left, and then there's no more. Okay? And the question is, how many are there? So you can use this formula. N lambda equals d sine theta. Okay?
And it's only 90.
Yeah.
It's 1.
But, well, let's see.
It's double. It's double. That's it.
And we'll have to double it, yeah. But this here, n lambda, must be less than d because sine theta must be less than 1 because theta must be less than 90. Can you see? N lambda equals d sine theta, so that means n lambda must be less than d. Why can't theta be 90? Well, if theta was 90, it would be like this.
Oh.
And it wouldn't hit the wall.
Oh, yeah.
So the theta has to be less than 90, so it'll hit the wall.
Yeah.
So this sine theta must be less than 1 because theta must be less than 90. Yeah. So that means n must be less than d over lambda, which is equal to 1 over 0.165, which is equal to
6.06.
So n must be less than 6.06. So what is the biggest n, the maximum?
6.
6. What about if this was 6.96? What would it be?
6.1.
If it was 6.96, what is the biggest n?
6.1.
7?
No.
6.
6. Yeah.
Why?
You can't have 7.
But you say it's roughly. Oh, it's okay, I know.
Yeah? No, Ben. Only this one is roughly. This one's exact.
Okay.
Yeah. Okay. Whoops.
What's the question? Maximum.
Maximum order.
Order.
Yeah. How long until the boy no longer hears the humming? So, how long is this? We have 12, because you have positive and negative.
Yes.
12s, which is equal to 12 times, what was the s? 0.33.
Yeah.
Which is 4.
Where's point?
That was answer. This is part 5 now. 1, 2, 3, 4, 5. Okay, so that's 4 meters. Yeah? 12s is 4 meters. S we said was 0.33.
Ice is between two.
Two fringes. Yeah, 2 bright spots, yeah. And there's 12 of them. 12 S's here. Because we said the biggest one is 6. No?
Oh, I'm confused.
What's confusing you?
6.
No. It goes from 6 to minus 6. That's 12. No? What's confusing you?
Okay.
It's okay? No, it's not okay.
So from normal to from n equals 0 to to the top is 6.
Yeah. And from 0 to the bottom is 6. So the boy goes from -6, -5, -4, -3, -0, 1, 2, 3, 4, 5, 6. He walks all of that.
But theta is 19.3.
No, that's only for number 2. Because my question was, what's the angle for the second?
Okay.
Yeah?
Okay.
Right, now look, the boy walks, how fast does he walk? Oh no, the question is how long. I meant distance. So the boy walks for 7 meters hearing the sounds. But then after number 6, no more sound. So it's for 4 meters. Okay? This is an exam type of question. Yeah? Because it has multiple parts.
What's the question? How long?
I think that should really say how far. Like the distance. Alright, do you want to try and write this down? If you can. I'm sorry, it's a bit... Do you want to look at... What way do you want to write this down?
Question and answer is better.
Okay, which should I put up first?
Maybe picture or draw?
You just want to draw the picture? Yeah. Can you see my picture? Ah, yes, okay. I know. Physics is difficult. Chemistry is difficult. English is difficult. The only thing that's not difficult is maths.
What?
You're right. So where's the n equals 0?
In the middle. Always in the middle. Always in the middle, yeah.
So it is no matter from which door coming out.
The middle of the 2 doors. No, it comes out of both doors. The sound comes out of both doors, and in the middle of the 2 doors is the biggest, brightest fringe. Got it?
Yes.
Now, were you good students and did you do your physics questions?
Huh?
Did you do your questions? Are these done?
No.
Well, I thought you did these in class.
Oh, really?
too tired for this.
I don't think. Oh yes. But no fault. No. Yeah.
Listen, I want to give you the answers. You can check if you're right or wrong.
Okay.
And then the questions you got wrong, we'll do them in the tutorial tomorrow. Do we have 2 hours tomorrow?
I don't care.
Yeah, me too.
I very care the presentation.
Yes.
That's math.
Just maths tomorrow? Physics on Wednesday?
Wednesday 3. Why they always give us timetable like these?
How many hours on Wednesday? 1 or 2?
We have maths in the morning, 2 o'clock, 2 hours in the morning.
But how many physics?
1.
Just 1? Okay, we'll do tutorial. So whatever questions you get wrong, okay? So can you go to page 105? I want to give you the answers. I want you to check if you got them right. Did you do any of these questions, Go?
Sure. Oh, I think I did. We did this in the class.
Yeah, okay. So 105. Question 1. The answer is...
Wait, I didn't write answer in here.
No, but... You can, no. You can write my answer in here and then you can check if you got it right.
Good.
Ben, you can just tick if you got it right or not. So, the answer for the first one, I think, is 2.2 millimeters.
2.2 millimeter.
Did you get that?
It's 0.022.
Yeah. The next one is 375 nanometers. Nanometers.
It's minus 9.
Yes. Yes. Number 3, the answer is 10 meters.
10. Okay.
And number 4, the answer is 16.5 millimeters.
Millimeter.
Minus 3.
3 minus 3.
Okay, for the next lesson. So Ben, how many did you get right? Did you get them all right?
2.
2. Okay. Next one. Question 1 is 12.5 centimeters.
12.5
5. Yes.
centimeter.
cm. Yeah. Number 2 is visible light.
That's what we
What's
learned
visible?
in chemistry.
Huh?
That's what we learned in chemistry. Visible light.
Good. Number 3 is 10 to the 15 hertz. Number 4,
10 to the
15. Power 15. No?
Wow.
Number 4. What's wrong, Ben?
Okay.
Number 4, the answer is no.
No. Okay.
Number 5, gamma and AM radio.
Gamma ray.
Gamma and AM radio.
Gamma. No gamma.
Not gamma.
It's X-ray.
No, look, after X-ray is gamma. Look under X-ray. Can you see it?
Gamma and
Gamma.
Okay. Gamma.
B, X-ray and visible. X-ray
S-ray.
and visible.
S-ray.
R-A-Y.
X-ray.
A-Y.
Yeah.
X-R-A-Y.
X-ray and visible.
Right. Okay. Why can't you use visible light for C? The lambda. The size of the lambda is too big.
Okay.
Yeah. D, I think the answer should be UV.
Yeah.
Good. Did you try the next lesson, Ben?
No.
Ben! Okay, I won't give you the answers until you try them first, okay? So, this was a big lesson. What have we got? We've got 10 minutes left. So you can have a choice. You can either start this one, or you can go back to the previous lesson, Ben, and start from this one. Your choice. Gao, you can only really do this one because you missed the last lesson. Yeah.
Can I do presentation? It's saying no physics.
Okay, wait, hang on. You want to work on your presentation on your laptop, right? Only if you promise me before. When's our physics class? Wednesday. We have physics on Wednesday.
Yeah.
You must promise that you'll have all those questions finished by Wednesday.
Tomorrow, if I do the best presentation,
Yeah.
I think I can.
You'll stay up late to finish the physics as well.
No, the physics is for Wednesday.
Yes.
Yeah, so we stay up late on Tuesday.
When's your presentation?
In the morning.
Yeah.
Yeah,
So
I mean,
you can do your physics after the presentation, right?
If I do the okay, I don't see the
Huh?
you don't want to say he did upside with success, so you don't want to say this.
Okay.
I think I do this. Cause I can't remember.
Okay, you're going to do your physics now. Ben, what are you going to do now?
chemistry.
Chemistry? Really?
It's oxidation reduction.
You don't want to do physics now?
What's no lines, please?
No energy?
Yeah.
I know.
Line spacing.
That's the... Remember the picture I showed you of the diffraction grating? The line spacing is just the distance between the slits.
Also, it's fringe.
No, it's more like the D, the small d. Yeah. Be strong, Ben.
Oh.
So, if I show you this picture here, go. Just load it. So the question says the line spacing is what, like 300,000 or something?
There's diffraction grating.
Yeah.
Height. Yeah, like 300,000 lines per meter.
So what that means, pictures loading, if you look at all these slits, in 1 meter, there's 300,000. Now we only care about the distance between 2 of them. So you have to calculate that.
Huh? Oh, so one.
Just 1 divided by 300,000, yeah.
Panic. If I lost my phone.
There. So there's 300,000 of these slits in a meter, is what it's saying.
Okay. 3.33.
Yes? What's wrong, Ben? You look shocked. Are you shocked?
No.
Okay, good. Do you think Summer will watch this later? Well,
Maybe.
let me ask Gao. Did you watch the videos you missed? On Friday?
No,
Oh.
I'm doing my presentation. I will. Yeah, because I asked Ben how many pages should I make.